Hello everyone, welcome to Nevin's Data Lab. In this video, we will learn about the logistic regression. Unlike linear regression, in logistic regression, we calculate the probabilities instead of a single value. In logistic regression, we basically classify the points. Let's say you have like points like this, like this. So you'll have to create a model that will accurately classify whether the points belong to either this class or this class. So how we do that is we will pass the value to the sigmoid function. So basically the value of our y would become this instead of y is equal to wx plus p. We'll just put it in over here. Sigmoid function is basically 1 by 1 plus e raised to power minus x. This will basically limit the values of the function to from 0 to 1. So the range of this function is from 0 to 1. There's a slight mistake over here. This should be minus. So this graph is basically the graph of the sigmoid function. Mm. Also, the other thing that's different from linear regression is the loss function. In linear regression, if you remember, we had used the mean square error loss function. For logistic regression, we would use the cross entropy loss function. Cross entropy loss function is this. This is out of scope of this. I mean, to explain this is out of scope of this lecture. I will create a separate video on this in the future. But for now, just think of it as this is the equation for cross entropy function. And we would also need to calculate the derivatives of this loss function like we did for linear regression for the gradient descent part. If you don't know what gradient descent is, I would highly recommend you to watch the first video again because in that video I had explained the basics of gradient descent and how it works. So we have basically calculated the derivative of this loss function over here with respect to W and with respect to B. So this is the gradient of the loss function with respect to W, and this is the gradient of the loss function with respect to B. So now that we know the basics, let's jump onto the code. In this video, I'm thinking of going in a more structured manner. So that is by implementing classes. So let's start class logistic regression. We'll generate the init function, which would contain the learning rate and the number of epochs. Let's set the default value as 0.01 and the number of epochs to 1000. We would also need a fit function, which would basically train the model. On a y, x would be our input and y would be our output. And in the end, we would need the predict function. This would take in x as the input and give us y as the output. Okay, so let's start with the init function. We can just set self.lr is equal to lr, epochs equal to epochs. We would also need the weights and the biases. So let's say just w is equal to, we'll start with none. This is just defining the variable, so we are not really initializing it over here. We'll initialize it in the fit step. Uh, so the weights would be numpy dot zeros of the length of x. Okay, let's just say n samples comma n features is equal to x dot c. So this would be n dot features, and we'll also have to import numpy, and we'll also set our bias to 0. Let's start with the actual training part. For let's say in range for the number of epochs, so that would be self dot epochs. Uh, First, what we have to do is we have to calculate the value of y like we calculated in linear regression. So linear y would be equal to, we'll have to do np dot dot, basically getting the dot function. I mean dot product of x and self dot w and adding the bias. And then our actual predictions from this logistic regression would be the sigmoid of this, sigmoid of linear y We'll have to define the sigmoid function for this. Def sigmoid y. Sigmoid is nothing but 1 by 1 plus e raised to power minus x. So how will we write this is, find this out, return 1 over 1 plus np dot exponential of minus y. So this is nothing but the sigmoid function. And we got our predictions. Now we have to calculate the loss. Um, so we take the derivative, which was like dl by dw and dl by db, like we did in the previous video. We can write this as 1 over n samples times np dot of x comma predictions minus. We'll have to take the transpose of this to get the dimensions correct. And this would be equal to, again, 1 over n. In this case, there won't be. And we'll have to take the sum of this thing. Next, we can update the weights and biases. So self dot weights, these are new weights, would be equal to self. We defined it as w, so self dot w minus learning rates dot learning rate times the derivative. Similarly, we can do it for bias. Okay, let's do the predict function now. So for predict function, we are basically doing the same calculation first, and we have to classify based on these predictions. So let's say the threshold is 0.5%, like class A if it's less than 50% and class B if it's more than 50%. Then basically class prediction would be uh, okay. Class prediction would be 0 if right. So class pred would be 0 if y is less than the threshold, else 1 or y in predictions. And we basically have to return the class pred. So that is it for this code. So the major differences from the linear regression would be the sigmoid function, obviously, the derivative, and calculating the class prediction based on some threshold. I think we can just take in the threshold over here as well, 0.5, because that's the general case scenario. Yep, now let's test this code. For testing this model, let's import the breast cancer data from scikit-learn. From Sklearn, import datasets, and df would be datasets dot load breast cancer. Let's just see if we have gotten the dataset correctly. We'll just do this. As you can see, we have the data. Let's just clear this one out and continue the code. X comma y is equal to, and now we'll have to split the data. So let's say split index is equal to 0.8 times the length of x, and we'll have to make this an integer because of obvious reasons. Next, x train comma x test is equal to x split idx comma x split idx till the end. Similarly, you can do it for y. So now we have the training and testing data. Next, what we can do is uh, initialize this thing. We can, like random linear regression, logistic regression is equal to logistic regression, and we have to initialize it nothing because we have the default parameters. And to train this logistic regression model, we just have to put lr.fit, and we need the x and y values. So basically, the x train and y train values, and then we can do lr.predict. It would be x test. And let's print if we are actually getting like 0, 1 values, and if everything is working correctly. Okay, so we have an error over here. Yeah, I mean, obviously, we don't have to use the length of n features because n features is the number of features. So let's run this again and let's see if we have any errors. Yeah, so we are getting the predictions correctly. I mean, I don't know if it's correct. We can have to check the accuracy. To get the accuracy, let's create another function. Accuracy ypred, comma, children, return. This is equal to numpy.sum. How many times this ypred is equal to y divided by the total number of y. This- Okay, wait, I think I did some mistake. Yeah, I think this should get the accuracy correctly. So let's print. Just and directly print accuracy of y test and give ypred is equal to this thing. And we are given ypred comma y. So let's check. As you can see, we're getting a 91% accuracy, which is very good. So yeah, that's it for this code and this video as well. Thank you so much for watching. If you have any doubts, please leave your doubts in the comment section and I will make sure to answer them. See you guys in the next video. Bye bye.